Hi kids, sorry I'm not here. My daughter's sick, so I got to kind of take care of her. So I made a little lesson for you for today. Today's lesson should not be that difficult. Um, it's quadratic inequalities, which probably means nothing to you now, but when we get done with this lesson, you're totally going to understand what it means and what it looks like and what you need to do when you see those types of problems. So what I want you to do right now is your yellow note sheet should be passed out to you by the sub, and what you're going to do is you're going to flip it over, and you're actually going to do these two problems, level 1 and level 2, as your warm-up. Right, just factor completely. Do not solve because technically there is no equal sign, so I apologize for that. You are not solving. Pause the video and then restart it to see the answers. All right, so you should be finished. So number one, you should have gotten the answer of x minus 10, x plus 6. Again, you're not solving, there's no equal sign. So this was easy. A was 1, so what two numbers multiply to 60 and add to negative 4? Bam, negative 10, positive 6, and they have to multiply to negative 60. Now number 2 is a little bit harder. All right, it's a level 2. Reason being is your A value is a composite number, meaning that it is going to have more than just 1 and 1 as a factor. It's going to have 1 and 4 and 2 and 2, as well as 21 having factors of 1, 21, and 3 and 7. Not the hardest, but definitely probably needed a little more work than the first one. So what you should have gotten as your answer is v plus 3 times 4v minus 7. Now if you wanted to put the 4v minus 7 first, that totally is correct. But again, this is just my answer. If you flip-flop them, that's totally fine. But the v and the plus and 3 have to be together, and the 4v and the minus 7 have to be together. So that was your warm-up. Again, very similar to your quiz that you took yesterday. So hopefully those have been passed out or passed back to you. If they're not, just come up to the desk and grab yours so you can begin working on quiz corrections. Those are due on the day of your test, which is next week. So look at your calendar, see what day that is. So here we go. Without further ado, turn your yellow note sheet back over, and we're going to get started with today's lesson. So today what we're going to do is we're going to solve exponential inequalities, not linear inequalities. I'm a knucklehead. It's exponential or quadratic inequalities. I apologize. So we're going to determine whether a quadratic function is positive or negative when graphed, and then graph your solution to a quadratic inequality. So it's just quadratic inequalities today. So again, a little mini warm-up. So if you can remember from Math 1, what key features do you need to determine where a quadratic function is positive or negative? Now, one thing that I like to do to kind of help me out, especially with this entire unit, is draw little mock graphs. All right, so if I got my x and my y axes, all right, if I have a parabola here, here's a parabola, here's a parabola, what do I need to know in order to determine what and where a function is positive or negative? Well, you probably need to know where the function is positive. And what does positive mean? Well, positive means above the x-axis. All right, so this and this are where your function is positive. It's above the x-axis. So if positive is above the x-axis, what would negative mean? Negative means below the x-axis. And that would be this. So what would we need to determine where is it above and where is it below? Well, what do you need are x-intercepts. Boom and boom. You need x-intercepts to do this. Now, all unit long, we've been doing something called factoring. And factoring, when you factor quadratic, what you are doing is you're finding x-intercepts. You're finding them. And this is part of the reason why. When you find x-intercepts, that's going to allow you to find where functions are positive, where functions are negative, and also find where functions equal 0, which is what we have been doing when I've been asking you to solve. You've been finding where your function equals 0. You've been actually finding your x-intercept. So today what we're going to do is we're going to find x-intercepts by factoring, and then what we're going to do is use those x-intercepts to see where the function is positive, where is it above the x-axis, and where is it negative below the x-axis. So down here is the start of our notes. Now, just a reminder, we haven't done video lessons in a while, but when you are doing video lessons, make sure you pause if you need to pause, rewind if you need to rewind, and then if you have to, fast forward if I'm going too slow. But mostly I'm trying to go faster so you can just pause and not have to go faster. So let's start. Positive and negative. Now I kind of just went over this, but it's always good to write it down again. Positive means where our graph is above the x-axis. All right? And all we're doing is referring to what x values make your graph go above the x-axis. So we're refer to x values when you do this, all right? And negative means below the x-axis. Now, today, we're going to see this positive and negative in an inequality. I'm not going to ask you, where's your function positive? Where's your function negative? I'm just going to ask it using an inequality. So, here's the deal. If you had a quadratic equation that looked like this, like x squared plus 5, oh, come on. Okay, let me rewrite it. X squared plus 5x plus 6. But you saw this is greater than 0 or greater than or equal to 0. This right here means greater than 0 means above the x-axis, or positive. That's what it means. So if you're trying to look for where's your graph greater than 0, that means above the x-axis. If you have something, let's say the same one, x squared plus 5x plus 6 is less than or equal to 0, all right? This inequality, less than, you want your function, where is it less than 0? That means below the x-axis, which means negative, all right? So that's what you're going to be looking at today. You're not going to be told, hey, where's a positive, where's a negative? You are just going to look at it as a inequality. So you're going to have to be aware of your inequalities to determine, are you looking for the positive part or the negative part? You will never be looking for both parts. You are only going to be looking for one or the other. So let's get started with example 1. Now, this is example 1. I have steps here, all right? And I'm going to talk about these steps for the first one and then refer to them for the rest of them. All right, but here is step 1. So you're going to want to take diligent notes with your steps of what we're going to do. All right, so for this first equation, it says, for what values of x is x minus 2 times x plus 10 greater than 0? So if you read this, all right, number 1, what you want to do is you want to identify what they're talking about here. So this sign means greater than. So greater than means positive. So where is it greater than 0? That's positive. So we're going to want the stuff that's above. Now, we'll come back to that in a second. So over here, I have highlighted steps for solving inequalities. So I got them all. Like, number 1, get your inequality equal to 0. Well, clearly it can't equal 0, but you just want the inequality to have 0 on the other side. Then the second step is factor out a GCF, then factor into 2 binomials. Number 3 is solve for your x-intercepts. So that means figure out what each individual x-intercept would have to be, and then make a mini graph, all right? So let's just go up to this point right now. So number 1, it's set equal to 0, perfect. We don't need to factor out a GCF because this is already factored. It's already in 2 binomials. So now we just solve for x-intercepts, meaning that we're going to take each one of these, x minus 2 and x plus 10, and set them equal to 0. Set this equal to 0, and we're going to solve. So add 2, so you get x equals 2. Minus 10, we get x equals negative 10. Now, these right here, 2 and negative 10, these are your 2 x-intercepts. So what I'm going to ask you to do for all these to help you out is draw now a mini graph. Draw a mini graph with these x-intercepts on here. So negative 10, again, I'm just kind of approximating. This is negative 10, and this is 2. All right, now, those are your 2 x-intercepts, but we got to have an idea of what our graph looks like. So the next thing is determine what the shape looks like also. So shape comes from your a value. If you look at your a is 1. If you were to go x times x, it would be 1x squared, meaning that if a is 1, so a is positive, means that this thing's going to go upwards. So I'm just going to make this go up, make it go up, and then this is going to go down somewhere. So this right here is basically what your graph is going to look like. So this is going to help you now back to what we said at the beginning. We want to know, where is this function greater than 0, or where is it positive? Well, this guy is positive here, and it's positive here, okay? So those two values are where it's positive. So what we're going to do is we are going to list out, where is this thing positive? It is positive, okay? It's positive for these different sets of x values. So this right here are going to take x values from negative infinity all the way to negative 10. We're going to put a bracket because you cannot include it. Now, we've never done this before when we have two sets of values. So what we're going to do is we're going to put a U here. This U stands for union. That means union, all right? Basically, it means we're taking this and this next part. So now what we're going to do is we're going to write the second part on here. So we said from negative infinity all the way to negative 10, that's above the x-axis. Now between negative 10 and 2, that's below, so that would be your negative part. We don't want that. And then from 2 all the way to positive infinity, that's when it goes back up to positive. So this right here is our answer. That's it. Now, notice here, I said identify. The last step is identify and write out your solutions. Be aware of brackets and parentheses. Your inequality will tell you if you use brackets or parentheses. Brackets are used when you have a greater than or equal to or less than or equal to. All right, parentheses are just when it's greater than or less than. Understand, when you're looking for when it's greater than or equal to 0 means you can include 0, so that's when you would need a bracket. All right, that's when you need brackets for these two. But if you can't equal 0, that's when you pop on some parentheses there. Okay? But this is our answer. So all of this is needed. So setting it equal to 0, factoring, solving. This mini graph is so crucial, and then you just write it out. So if you have two parts, you use a union. So let's try example 2. Let's try a couple of these now. So here we go. Now, mine's going to look a little different, and you're just going to work below. So solve. And solve basically means, all right, look at this and determine what it's asking. Since there's an inequality, that means that we want all values that are either positive or negative. But based on this is x squared blah, 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 is less than or equal to 0. So values that are less than 0 are negative. So we want negative or below the x-axis. All right, that's what we want. So that's just what we want to keep in the back of our head. So in order to do that now, we need to find our x-intercept so we can draw this graph so we can determine what we want. So I'm going to factor this guy out. So we got parentheses, less than or equal to 0. Now notice I automatically just broke it into two parentheses here because number one, my a value is 1, and I can't factor out a GCF. So what I'm going to do is I'm just going to say, hey, what two numbers multiply to 7 but add to 8? Well, that's x plus 1, x plus 7. So those are your two factors. Now, once you factor, you now solve. So we're going to go x plus 1 equals 0, x plus 7 equals 0, and we're going to solve. So you're going to get x equals negative 1 as one of our x-intercepts, and x equals negative 7 as our other x-intercept. Sorry, that's a 7. Again, I'm writing on my computer, so my handwriting is terrible. You really want to make sure that you have some nice handwriting so you can see your work. All right, so here we go. Ready? So now in order to do this, we got to graph it, and then we're going to identify our stuff. So we have two x-intercepts, negative 1, so here's negative 1, and then negative 7. Negative 7. All right, now look back at your problem. What was our a value? Our a value is 1. So if our a is positive, that means it opens upward. So this guy's going to go up, up, and then it goes down over here. So now, this is our graph. Our inequality said we want to know the values that make this less than 0 or negative below the x-axis, which means it's referring to this stuff. So what values of x fall under there? Well, the values of x that fall under there are between negative 7 and negative 1. Now, because it's greater than or equal to 0, it's not going to be a parenthesis, it's going to be a bracket here because we can include negative 7 and we can include negative 1 to being values that make this thing under the x-axis or equaling the x-axis here. So this is your solution here. These are the values of x that make this thing negative, that make this thing go below the x-axis here. And that is just found by us making our mock graph based on our a value and our factors, our x-intercepts here. All right, number 3. All right, now number 3, this one's fun. So if you look at number 3, all right, this is all funky. Our first step is make sure that this thing equals 0. Well, it doesn't equal 0. So what we have to do is we have to make one side equal 0. Now, as I told you in the past, I always try to move things to make my a value or keep my a value positive. My a value right now is negative. Therefore, I'm going to move this. So I'm going to add x squared, and I'm going to subtract 8 on both sides. So I'm going to subtract 8, and I'm going to add x squared. Now, notice where I put it, all right? I moved them over, but I put the negative 8 underneath the 1 because they're like terms. You're going to have to combine those. And I put the x squared out in front because you always want an x squared, x constant. So I rewrite it as x squared. There is no x value here, so we go 8x. That's going to stay the same. And then we combine like terms. Negative 1 minus 8 is negative 9. Now you keep the exact same inequality sign, and then you put your 0. So this is what we're working with now, right here. Bam. This is what we're working with. So got it equal to 0. So now I try to factor out a GCF. Can I factor out a GCF? No, I can't do that. Now, if you kept everything the way it was and moved then everything to the right side and left your a value negative, you would have had to factor out a negative 1 as your GCF. But because we thought beforehand, there's no GCF needed. All right, so here we go. So now we're going to factor this. All right, so we factor it and we say, all right, what two numbers multiply to 9 but add to negative 8? Well, that's going to be x minus 9 and x plus 1. Because negative 9 plus 1 is negative 8. So now we set each one of these equal to 0, negative 9 equals 0, x plus 1 equals 0, and we're going to find our two x-intercepts. So our first x-intercept is 9, and our second x-intercept is negative 1 when we solve. So those are our two x-intercepts. So to help us out here, we're going to graph this. So we got an x-intercept of 9. So here's 9. And then we got an x-intercept of negative 1. Okay? And now I got to look back at this equation, not at the original one. The original one's a little funky. We look back at the one that we factored. So this is what we're looking at here. And you're really looking at your a value. My a value here is 1, which means it's positive. So if my a value is positive, that means this guy opens upward. So I'm going to go up, I'm going to go up, and there's the down. So now, that's my graph, and I'm going to go back to this highlighted problem, and I say, all right, my quadratic, I want to know where my quadratic is greater than 0, which means positive. Where is it positive? Well, positive means above the x-axis, so it's positive here, and it's positive here. So this is another union problem. We're going to need to have a union. We're going to have two sets of answers. So we're going to have from negative infinity, when x values are negative infinity, all the way to negative 1. Now, take a look. Do we need a bracket or parenthesis? Because there's no equal to, we're going to do parenthesis, union, because we now need to include the second one, 9 to positive infinity, and parenthesis there. This is your answer. These are your x values that when substituted in here will make your graph go above the x-axis. That's awesome. So we got one more example, and what I want you to do, I want you to try this one. All right, I want you to try this one and then play this, and let's see if you got the same answer as I did. Okay, so pause it and then play it when you're done. All right, so here we go. Ready? Number 1. I look at this and it's set equal to 0. I'm cool. I realize right away my a value is negative. Now that should tell me two things. Number 1, I'm going to have to factor out a GCF of negative. And number 2, my a value is negative here, meaning that my graph is not going to open up. My graph is going to open down. So that's going to be something a little different than what we've seen. So here we go. I got to factor out a negative, so I'm going to be left with 3x squared minus, sorry, I just want to make sure it's legible, minus 8x, and then plus 4 is greater than or less than 0. Sorry. So now I'm going to look at this stuff, and I'm going to try to factor this into two binomials. Now, this is a little more complicated factoring because your a value is not 1, but it's not super hard. So we're going to say, all right, ready? I'm going to factor this sucker like this. I'm going to say, all right, what two numbers multiply to 3? Well, that's 1 and 3. So I got 1x and 3x. And what two numbers multiply to 4? Well, that's 1 and 4 and 2 and 2. So you should have found the right combination, which is 2 and 2 will help you get this -8 if both of them are negative. Because 1x times 2 is -2x, -2 times 3 is -6x, -2x, -6x gives you -8x. See? So, there we go. But now, these are your two factors, and we're going to set each one equal to 0. So x minus 2 equals 0, and 3x minus 2 equals 0. And we're going to solve. So this one, you get an x-intercept of 2. Sorry, of 2, not 22. Sorry, 2. All right, and then here you get an x-intercept. So you'd add 2, divide by 3, so it's 2 over 3. I would not put like 0.6 repeated. I'd leave it as 2/3. So now these are your two x-intercepts that we're going to put on our graph. So I'm going to make my graph here. I'm going to put my two x-intercepts. So I got 2. So 2 is about here. And 2/3 is smaller than 2, so I'm just going to put 2/3 right here. Now, anytime I put my x-intercepts, I always put the number right underneath it or right to the side so that I know like where my values are going to fall. Now, the last thing we need to do is see what our graph looks like. Because we're making a mock graph, we looked before. We said, hey, our original problem, our A was negative. Our A was negative. It was not like we can remove this and do things around, right? So our A is negative, meaning that our graph is going to open down, down, and then up, which will give you a different set of values if you were to have drawn this opening upward. So here we go. Now that we got our graph, let's go back to our original problem, or the one that you factored, but the original one, and you say, what does this sign tell us? Well, we're asking ourselves, given this quadratic, we want to know where is this quadratic less than 0. So less than is negative. And negative means where is it below the x-axis? So this again is going to be a union. You're going to have a union answer, meaning our solution is going to be -infinity all the way. So from -infinity all the way to 2/3, you're going to have negative. Your graph is going to be downward. And then at 2/3 to 2, it's going to be above. So we just say, all right, well, we're not going to include that. But then we're going to go union 2 to +infinity, because that's when it goes back down again to the negative portion, and that's what we want. So this is your answer. So anytime you're trying to give two sets of answers, you use this union symbol to help you out here. Okay? So for examples, you should be good. So what I'd ask you to do right now is get your homework from the sub, and I want you to keep this going because I want to show you a change that I need you to make on the back side of your homework, all right? So get your homework, pause this, and then replay it so you can see what I'm doing, all right? So here you go. This is what your homework looks like, worksheet 8. All right, the first 8 are nice problems. Now on the back, there's three word problems. I need you to change number 9. I need you to change the 32x to 24x. So just scribble it out and put 24x above it, because what you're going to do with these, and I'm just going to kind of walk you through this first one, is you're actually going to set up your inequality by reading it. It says a flying squirrel jumps from one tree to the next. Its height in feet per second into the jump is given by the equation -16x squared, and then I get rid of this, 24x plus 4. So that's your equation. Now, your question says, when is a squirrel more than 12 feet above the ground, or higher than 12 feet above the ground? So what we're going to do is we're going to write out our equation, -16x squared, all right, plus 24x plus 4, that's your equation. But we want to know, when is this thing greater than 12 feet above the ground? You see that? So that's how we actually start this equation. You start it not set equal to 0. You start it set equal to what the question's saying. We want to know, when is this guy above 12 feet? Now, this is where you start. But can you even solve anything like that? No. The rules are, number 1, you can only solve if your graph is set equal to 0. So this is where we start. Now we say, all right, I got to solve for my value of x. So I'm going to have to subtract 12, and then I get started. So -16x squared plus 24x, and then 4 minus 12 is -8, which is greater than 0. So now that we have it equal to 0, now we can factor and solve. And these are going to give you the values that will make this greater than 12 feet above the ground. So, all right, now I'm going to kind of help you out with this first one. So take a look. Number one, my A value is negative, so I know I'm factoring out a GCF first. And I'm also going to try to factor out a number. 16, 24, and 8 are all even, and they're all actually multiples of 8. So I'm going to be able to factor out a negative 8, which is going to make this problem a lot easier than what it originally looks like. So by factoring out a negative 8, I'm going to be left with 2x squared. 24 divided by negative 8 is negative 3x. And then, come on, buddy, leave that there. And then negative 8 divided by negative 8 is positive 1. And that's awesome, because now all we're going to try to do is factor this guy. Let's factor this guy out. So I'm going to leave this negative 8 here, parenthesis, parenthesis, greater than 0. So here we go. Ready? What two numbers multiply to 2x? Well, that's 2x and x. What two numbers multiply to 1? That's awesome. 1 and 1. And then we need this to be negative 3. So negative 3 means that both of these are going to have to be negative, because 2x times negative 1 is negative 2. Negative 1 times x is negative 1x, giving you a negative 3x. So these are your factors. This is it factored out. So now to find your x-intercepts, you're going to set each equal to 0. So 2x minus 1 equals 0, and x minus 1 equals 0. And then you're going to solve. So you're going to get one x-intercept of 1/2, and then you're going to get a second x-intercept of 1. These are your two x-intercepts, right? This is going to be needed to graph. So I'm going to graph this sucker out. So I got an x-intercept of 1/2. All right, here's 1/2. Come on, buddy. And then I got an x-intercept of 1. Now, yes, it's not graphically accurate. Like, clearly they're not that close together or that far apart. But it just helps me out here. Now, going back to this problem, I need to know what this looks like. Does it open up or open down? Well, since our A value was negative, this guy opens down, 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 and this models our graph. This models our squirrel jumping. All right. Now, because we're looking for when is the squirrel 12 feet above the ground, these x values are referring to time. So when is this squirrel greater than or above the ground or greater than 0? We're looking for when is it above the x-axis. So what values make this thing go above the x-axis? Well, our answer is going to be 1/2, comma 1. So the x values of 1/2 to 1 are what's going to make this thing go above the x-axis. So what I'm going to write is, when is the squirrel above 12 feet above the ground? I write between 1/2 and 1 second. That's when it's 12 feet above the ground. That's what we did in this problem. So you're going to do that for number 10 and number 11, all right? I'm going to tell you a little hint on number 11. You see this A value is 1/2. You're going to want to factor out 1/2, but you're also going to want to make sure you use your calculator to see what happens here. When you factor out a 1/2, your values of B and C actually will get bigger, right? Because factoring out a 1/2 actually kind of does something a little fun. So I want you to try that. I put these answers on Google Classroom, or actually like in our folder. So make sure you look in the folder for the answer key for 3.25 the inequality. So check those, see what it is, and then I'll be back on Tuesday or Monday. Actually Tuesday, because I'm not here Monday. And we'll go over those. Monday, you will again be given a test review packet, so make sure that you're going through that. And Tuesday, I'll be able to answer any and all questions. All right? Thank you, kids. You guys rock.